Hi guys, my name is Mr. Lead, and today we're going to be doing a little simulation. It's often good to do these sort of simulations because they help really cement knowledge. They help us really understand the science that's actually taking place. What we're going to be simulating here is seafloor spreading, the theory of seafloor spreading as in accordance to Hess. And more specifically, we're going to be simulating magnetic striping. Now, if you remember from the last video, magnetic striping refers to when we see patterns of magnetite that are orientated in different ways. Now, I actually have some magnetite here with me, and so I can explain to you and show you what magnetite will do in seafloor spreading. All right, so in front of me, I have two pieces of paper taped together. I've got some bulldog clips, but the thing I want to focus on right here, right now, are these little pieces of mineral. These minerals are magnetite, and you can see that because they're magnetic. They're attracted to magnets, and they get attracted to each other as well, like that. Now, so what I discussed in the last video was that magnetite will always point north. You'll always see the domains of magnetite orientated north. So if we're saying north is up this way, they're all going to align in that direction. But if north was pointing this way, they're all going to align in that direction. Now, what we see with seafloor spreading and with magnetic striping is that not all magnetite that are frozen in their place, that are stuck in their rocks, are orientated in the same direction. So the way magnetic striping works is we have all this magnetite. Say all this magnetite was orientated with north this way. Now, if we were to spread apart and have more rock get formed here, this new rock that comes up from the sea floor has also got new magnetite in it. And if it just so happened that the rock that comes up at this time came up at a time when north was pointing the opposite direction, then we're going to see these magnetites also orientated in a different direction as well. If we looked on the microscopic level and we looked at the direction of the magnetic domains, they're all going to be pointing in a different way. So we will be able to draw a pattern on the ocean floor with the way the magnetite is facing. We'll see that this magnetite is pointing with north up this way, and this magnetite is pointing with north down this way. And then if we ever see that the poles switch again, and we see more magnetite forming, we might find magnetite with north pointing up that way again. So the magnetic striping shows us that two things. It shows us, one, not all of the ocean's crust is formed at the same time, and two, it shows us that the Earth's magnetic poles actually flip sometimes. And this is probably because of convections that are happening in the core of the Earth, which is what the iron core is what actually gives us a magnetic field. Now, what I want you guys to actually be doing today is to actually simulate the experiment or the demonstration I just did here. So you can find this demonstration on page 401 of your textbooks. You're going to be simulating magnetic striping. What you're going to need is you're going to need to take two pieces of blank paper and tape them down in the middle and put some either clothes pegs or bulldog clips on the ends to weigh it down. You're also going to need some different colored markers or pencils. And you also, what I'm going to use, you don't necessarily have to use this, but what I'm going to also use is a magnet and a compass to show that the magnetic poles are sometimes flipping. You might not have a magnet and a compass, so you don't actually have to have that handy. Okay, so here's what you also need. You're also going to need two chairs or two tables put close together. So what you're going to be doing with this experiment is this. So this paper here is going to represent magma. And the table here, the crack in the table, is going to represent a ridge, or it's going to represent a ridge. What you're going to need to do is you're going to put the piece of paper between the crack in the table. Bit hard for me to do it with one hand. Give me a moment. Okay, so I've put the piece of paper between the crack in the table. And so, once again, the paper represents magma. What you're going to be simulating, or what you're going to be doing, is you'll need to put your hand underneath the piece of paper and push up the magma. Try and make sure it goes separate ways there. You're going to push up the magma just a little bit, just to show that the new rock that is being formed here from the magma is spreading apart. Okay? Now, what's really important for you to do with this simulation, don't pull the piece of paper on top, because the magma is not being pulled from on top. It's actually being pushed up from underneath the earth. Okay? So you've got to make sure what you're doing in this simulation is you're pushing it on the magma from underneath. Now, when you push up a new piece, what you'll need to do is, to simulate magnetic striping, you take two separate colors, and imagine one color is going to represent a series of rock with magnetite pointing in one direction. So I'm going to say that red is when magnetite is pointing to north down this way. So I'm going to color in all of this red. Give me a moment. There we go, colored it in. And I put little arrows showing which way the magnetite is pointing. Now, I'm going to go under the table and push up some more rock. And at this point, I'm going to show with this magnet that the poles are flipped. And now, because the magnetite's all pointing a different way, I'm going to represent that with a different color. So I'm going to color this in now. There we go. And I'm going to keep repeating this process of pushing up some more magma. It's falling down. All right, I'm pushing up more magma, switching the poles of the Earth, and then coloring it in a new color. And I'm going to keep repeating this process until I will see an entire spread of seafloor. So you'll end up with something that looks a bit like this. And this is what the ocean floor looks like. We're going to see patterns on the ocean floor that diverge out from a central ridge. I really want you guys to have a go at doing this yourself, because it's when you do the things yourself and when you try these simulations for yourself, it really cements the learning into your mind. So make sure you're actually pushing the paper from below, and you'll see we've got some of these patterns where the rock is split apart, and you can see each half of the rock on the ocean floor here. So yeah, I want you to have a go at doing this. Take a photo of the end product, upload it to OneNote, and then also fill out the review questions in your textbook on page 401. All right, thanks guys.